Hello, Ross. For 2.6 on these proof of the rules and the combining the rules, I want to try examples from class using alternate methods. So example number 1 said if y is x squared minus 5 divided by x cubed plus 5, all to the exponent 4, we wanted to find an expression, simplified and factored expression for delta y by delta x with natural exponents. So what we're going to try this time is applying the power of a quotient rule here. I think what you'll notice, though, is that by trying to get rid of a power of a function rule by using a power of a quotient rule, you're actually creating 2 chain rules instead of 1. And you still have a quotient rule. So there's really no advantage. The only other suggestion that I've seen here is using Pascal's triangle to expand these, and that's just not an effective approach at all. So I think what we're going to see here is that using this approach is not going to be as efficient. I think in class I probably asked you to trust me, or I got this far and said imagine what it would look like. Well, now let's see what it would look like. It's another one of those cases where if we're not working under a strict time limit, if I'm not taking your test away before you feel like you're done, then there has to be some sort of incentive for students to develop efficient rules. So if a student were to do this, I can't guarantee that they will receive full marks because they're making a bad choice. I'm not interested in you finding the answer. I'm interested in helping you develop effective skills here. Because I mean, you could use Pascal's triangle to expand this. That would be a terrible choice. I think this is also a bad choice in this case. Let's see what happens. I'll stick to using the quotient rule, though. We'll use the product rule on the second example. Let's do the derivative of the outside of the the derivative of the power in the top with respect to the base multiplied by the derivative of the base with respect to x times the bottom minus the let's try the derivative of the bottom, the derivative of the outside of the bottom with respect to the inside multiplied by the derivative of the inside with respect to x times the top all to the exponent 4 all over the bottom. I'm not in a rush to square the bottom squared. I tend to find that students that skip this step will often accidentally write an exponent of 16 if they don't see it as a power of a power. One of the reasons why I'm not in a rush is because I have so many other things to do up in the numerator. I was wondering about, do I want to do the top times the root of the bottom to keep my bases in the same order? But then I realized I have some sort of collection to do here. And this tidying up, while it might make some of my numbers a little bit larger, it's actually just me preparing to find my greatest common factor. You might get excited about seeing a factor of 4, but then maybe I wouldn't find the factor of x on the same step. I don't think it's a great idea to try to factor from this stage. Try factoring from 8x times x squared minus 5 cubed times x cubed plus 5 to the exponent 4 minus 12x squared times, and here I think I'll put x squared minus 5's power first and x cubed plus 5's power second. Just, I don't know, I like having these in the same order. Okay, I'm not really expanding. I'm sort of multiplying monomials together. It's not that big of a deal. This is 2 groups of 4 groups of this base, which is 8 groups of that base, not 16 groups of that base. Okay. Division is an option here, but often students get into trouble when they start trying to divide outside of factored forms. You'll see students canceling things and not dividing it from another factor. So since you're going to be factoring anyways, I'm going to suggest you always factor before you divide. Okay. Now, things that would make absolutely no sense would include expanding these expressions. Don't expand those expressions, write it in a factored form. We might have to expand our quotient later. Let's see. Common to 8 and 12 is 4. Common to x and x squared is x. Common to 3 of those bases and 4 of those bases is 3 of those bases. And common to 4 of those bases and 3 of those bases is 3 of those bases. That will leave us with a factor of 2 and a factor of x cubed plus 5. A factor of negative 3x, and a factor of x squared minus 5. Threes are looking a little wonky. Okay, now I'll feel much more comfortable dividing these factors, simplifying, removing 3 factors of x cubed plus 5 from the denominator and from the numerator. What else needs to be done on this step? I shouldn't expand this. I shouldn't try to distribute this through. But this expression here is neither in a factored form nor a standard form. So we should expand it and collect it to at least get it into a standard form. Let's keep the 4 in the numerator, the x in the numerator, the x squared minus 5 all cubed in the numerator. We're going to remove 3 factors of x cubed plus 5 from the numerator. Let's downgrade these square brackets into curved brackets and see, I don't know. I was wondering if I wanted to try doing 2x cubed minus 3x cubed in one step. I'm going to say no. Maybe if I had a way of like editing videos in case I made a mistake. Didn't I do something here? Yeah, I removed 3 of those factors. I mean, I kind of regret my decision because I see I have a couple more steps to go still. By that I mean when I collect here, I'm going to have negative 1x cubed plus 15 x's plus 10 constants. So the problem that I have here is that this quotient, this factor, is written with a leading negative, which is considered improper. Some students have suggested, could you just write it as 10 plus 15x minus x cubed? And I'd be okay with that, but I'm going to guess that that's not a solution that you'd see. Let's remove a factor of negative 1. Let's place it out here. X squared minus 5 times x cubed minus 15x minus 10 all over x cubed plus 5 to the exponent 5. And that's the same answer that we got by using the power of a function rule first, followed by a quotient rule on the interior, but it took a lot longer, didn't it? It's not speed isn't an issue. Sometimes students need a little bit more time just because they work a little slower, and that's okay. But if you're working a little slower because you are avoiding learning how to do things efficiently, that's not okay. That will cause issues. Okay. So evidence of inefficiencies, of misusing rules, may result in, or will most likely result in, a loss of marks. Keep it in mind. Let's take a look at example number 2. And I'm trying to decide if I want to find f prime of 1 or find a simplified factor. Let's just find f prime of 1. Example 2 says, given f of x equals 2 minus x squared cubed divided by 4x plus 3 squared. We discussed how here with different exponents, we kind of have to deal with the quotient of 2 powers of functions. Writing this as 2 minus x squared divided by 4x plus 3 all squared times 2 minus x squared isn't going to be much more efficient, like removing one of these factors just so that you have the same number of factors. You could try that yourself and see that it's not a good idea. Let's say we're asked to find f prime of 1 again. Let's just try the curriculum approach of using products. multiplying by the reciprocal, let's say. We do have one advantage here, though, I suppose. We can eliminate one of our chains. Like, let me just ghost this in for a second. We don't need to do times 4x plus 3 to the exponent 2 bracket to the exponent -1, and then do the derivative of the power of a function if we just use our power of a power rule and write the expression like that. Okay. This approach, even though I may consider it to be a little bit less efficient, it is the way that the curriculum advertises that we do it, so it won't result in a loss of efficiency marks. Let's try using a product rule instead of the quotient rule that we did in class. Derivative of the outside of the first with respect to the inside multiplied by the derivative of the inside with respect to x times the second plus the first multiplied by the derivative of the outside of the second with respect to the inside multiplied by the derivative of the inside with respect to x. I hope I've got that right. And then we substitute now given these directions. F prime of 1 is going to be, let's see, 3. 1 squared is 1. 2 minus 1 is 1. 1 squared is 1. Maybe I don't write in a 1. -2 times 1 is -2. 4 times 1 is 1, plus 3 is 7. To the exponent -2 is going to be 1/49. Plus, let's see, 1 squared is 1, 2 minus 1 is 1, 1 cubed is 1. There's -2. Maybe I could have just gone -2. Let's deal with this factor of 4 here. And then we're going to have 4 times 1, which is 4, plus 3, which is 7, reciprocated, which is 1/7. Cubed is, what's 49 times 7? It's 50 times 7, which is 350, minus a group of 7, 343. I don't know my perfect cubes or my powers of 7. Yeah. Okay, so let's get a common denominator here. This was a power of 7, and this is a power of 7, so let's get a common denominator by doing that. And getting, what have we got here? -21, -42, 340 minus 8 340 which is -50 340. Yeah, that's the same answer that I got in class. Whew. Okay. Calculator will help a lot, but is not required for most of what we do in this course. And the only way that you're going to get better at numeracy is by practicing. So look for opportunities to practice.